Welcome to Artificiality. This is Dave Edwards. In this episode, I interview Scott Stephenson, CEO of Deepgram, a company that has built an end-to-end deep learning system for speech recognition. Scott comes at artificial intelligence from an interesting path. He has a PhD in particle physics and previously built deep underground dark matter detectors that he describes as James Bond-like layers underground. In the episode, we talk about why end-to-end deep learning sets Deepgram apart from other speech recognition companies, the differences between enterprise and consumer speech recognition, and how Deepgram handles accents and can help customers solve bias issues. I particularly like Scott's vision of Deepgram becoming a speech understanding company, where it's not just about the words, it's about what those words mean. Without further ado, here's my conversation with Scott Stephenson. Okay, well, thanks for joining the podcast. It's great to have you here.
Thanks for having me.
So why don't you start off with, it'd be great to get some background from you on Deepgram. So give us a little bit of the story of where it came from and what your focus is.
Sure. Deepgram is an AI company that builds enterprise speech recognition, and we're about 4 years old. The first 2 years were like a technical bet time where we didn't really go to market. We were a little more under the radar and just took the approach to throw away the old way to do speech recognition and replace it with an end-to-end deep learning approach. And actually, our background, or one of the reasons we were able to do this or to take this approach, is that we're actually not, or we weren't speech recognition people then. We weren't really experts then. But what we did is come from a physics background. And that bottoms up approach really gave us the confidence to attack this speech recognition problem from an end-to-end deep learning approach. And we took that the first 2 years to prove that out. And then now the last 2 years to actually go to market with it. And we've seen a lot of success.
Let me pause for a second and ask what you mean by a bottoms-up approach. You talk about throwing away the old way of doing speech recognition. How does that jive with being a bottoms-up approach?
Yeah, so I'm talking about a little bit of the reasoning behind it, which is like, if you were to take the problem of speech recognition today, a person speaking, recording that and digitizing it, and then converting that into text. If you were to just take all of the technology that's available today and say, we're going to start from scratch and build that, compared to how it was done in the past and how actually basically most companies in the world do it today, they would be totally, totally different. The old way to do it and the new way to do it is just very different. And the reason is there's been a huge advancement in the last 5 years on the artificial intelligence side, which is end-to-end deep learning. And so the old way to do speech recognition was, even the simplified way is like a 4-step, a very disparate process. But generally what you would have is you have a recording, like a waveform. You know, we've all seen waveforms, but that waveform gets fed into a piece of code that you would have a few engineers work on. And that code would do some background subtraction or try to remove noise reduction, things like that. And then that would feed into the next step, which is called an acoustic model. And that acoustic model takes the denoised audio and tries to guess which phonemes people are speaking. So that's like the alphabet of spoken words. Rather than being like A, B, C, D, it's like A, U, K, the, Z, those types of things. There's about 40 of them compared to the letters of the alphabet. But then that next step would be what's traditionally called a hidden Markov model, which is in these phonemes now get injected into another piece of code which tries to guess possible words. It's not guessing the words, it's not guessing the transcription yet, but it's just guessing possible words as a function of time. So every 40 milliseconds or whatever, is there possibly a word here, et cetera? And if so, which word out of like 100,000? There's a lot of vocabulary, specifically in any language, but English is like 100,000 words or more. So anyway, that next step, that's still not the end. There's another step where there's a step called beam search with a language model, you sort of tack them together, and you take a language model that's been trained on like Wikipedia or books or news articles or something like that. It's still not spoken audio, but then you pair that with a technique called a beam search, which takes all of those possibilities and tries to flatten them down into something computationally manageable. So you throw away a whole bunch of information, but in doing that, you can actually repair the transcript and make something somewhat readable. And so that's the old way to do it. And the new way to do it is say, man, forget about all the steps in between. Let's just inject audio, and then let's tell the target that or tell the model that its target is words at the bottom, and then let the model reconfigure itself and then try to figure out the best way to do it. And so this is really what end-to-end deep learning is about, is not breaking up the problem. And if you don't break up the problem, what that means is it's a fully data-driven approach. It's not engineers making decisions about how big your acoustic model or different things like that should be. You're letting the data determine how the model gets structured. And this gives you much better accuracy, but it also allows you to make custom models for each one of your customers, because now it doesn't take a year to make one model because of how labor intensive it is. Now you just let the data dictate that.
If this is a better approach, why are other companies sticking with the old approach? Is it just history and that's what they built, or are other people pursuing using deep learning as well?
They are, yeah. So I think you have to distinguish between end-to-end deep learning and deep learning as well, where you can inject deep learning into any step in that process. You could have a denoising step that uses deep learning, and then everything else is the same old way. Or you could put that in your acoustic model, or put deep learning in your acoustic model, which is a very common way for it to happen. You could go out to many legacy speech recognition providers, and that's what they would do. But all of the other stuff after that would be the traditional way. And the problem with doing that is you do get a gain if you inject some deep learning in there, but you don't get the full gain. And there's also a secondary effect here, which is it's still slow. I didn't mention that before, but the old way to do it is really, really, really computationally intensive on the memory side, the CPU side. And so you have this huge infrastructure spend that you have to have in order to do it, which is not true of end-to-end deep learning. It's about an order of magnitude better on that side. But nevertheless, the differences here are you just don't want to be you don't want to be spending all the computational effort. You don't want to be spinning up just a portion of it for deep learning, because the full end-to-end approach, it actually encapsulates all of that information.
And you talk about creating custom models for different customers. That seems to be counter to the current process, right? Where you have a single, Siri operating as a single system across an extraordinary number of customers. You're talking about creating custom models for individual customers, which I understand are enterprise customers. But what kind of challenges do you run into when creating a custom model for an individual customer?
Yeah, a lot of people don't know this right now, but the way that speech recognition works, even for Alexa or Google, is that they have one model. So they spend all their effort on making one model that's pretty good for everybody, but it's not tailored to any specific person or any specific vertical or any specific accent or anything like that. And this end-to-end deep learning approach with the data-driven approach, you can actually focus in on those areas and get a really good model that is much more accurate than what are generally called general models. A general model sounds great. It should generally be able to do everything, but it's sort of a jack of all trades and a master of none. And so if you can, you would much rather have a specifically trained model. And this is generally what our customers are doing. They're trying to, they're saying like, hey, I have a call center. There's a lot of background noise and everybody's talking about different products, or they have a specific task in mind, and maybe they have an accent, or your customers that are calling in have an accent, and then you can make a trained model that's specific to that. It still does a really good job on different speakers that are coming in. It's not like it's memorizing different speakers, but it's reducing its dependence on like trying to do a really good job at transcribing podcasts or basketball games or something like that. It doesn't need to do that anymore, because you allow the model to not think about those things. Like just forget about basketball games or whatever, focus on phone calls. And then it does a much better job in that way.
So it sounds like this is an advantage of focusing it on enterprise customers, right? So that an enterprise is going to have a single kind of use case, or they'll be operating primarily in a single geography, perhaps, or and so that model could be much more specific about what it's doing versus the Alexas and Siris and Google Assistants that have to service every person who picks up a device or a browser.
Yeah, exactly. And there's a big difference between what's happening on the enterprise side or businesses and what's happening in consumer. Actually, a lot of people in the last few years have started to have good experiences with voice. This is a new thing. 10 years ago, it was not a fun time trying to use speech recognition. But Alexa has come around, Google Home has come around, Siri has gotten better. But nevertheless, there's been positive experiences there. And this is actually pushing an awareness on the enterprise side to be like, man, where's our good speech recognition compared to the legacy stuff that was available? And unfortunately, you can't use the consumer stuff in the enterprise size, or I should say that a different way. You can use it, but you're not going to get the same accuracy. Like if you were doing the standard approach with the consumer side, where you're saying like turn off the lights or take me to 123 Main Street, or what's the next step in my recipe, or something like that, when you're using Alexa or Google Home, that type of language and that very short, like 1 to 5 second piece of audio that it had to transcribe is actually, it's not easy for the model, but it knows it really well. Also, you're doing it on specific hardware. So Google Home has a microphone array inside of it. Alexa has a microphone array inside of it. And it's specific. So it's multiple microphones that are figuring out which direction the sound is coming from and doing its own noise reduction and everything on board. This isn't normal when you're talking about just like a phone call and you're calling in. Phone calls sound like phone calls. They don't sound that great. A lot of times it's multiple people speaking all at the same time. And it's a long running conversation, half an hour long, et cetera. And that's just not what those other systems are built for.
I could also imagine, though, that the mental model that you operate with at work is different from the mental model of standing in your kitchen with a phone asking what the recipe is, right? Or setting a timer on your phone. That's the number one thing I use Siri for, is to set a timer. My expectation is that there's a task that I know that the phone can do or my watch can do, and I can ask it and it's done. But when I'm at work, I've got a more complicated design in my head about what I want to accomplish, right? When I want to extract something out of a conversation, it's much more complex than I would expect to extract out of a conversation at home.
Yeah, and you generally don't have the ability to fail in business or the enterprise side compared to, like, you would just try it again if the timer didn't work with Siri, right? On the consumer side, right? But if you have like a real-time conversation going on and you want your AI assistant to take notes for you, you can't go back and say it again because it missed it, So it also has a different redundancy and reliability that's needed.
So I'm interested. One of the things you talk about is handling different accents. And for those who have listened to the podcast before, you know that my wife, Helen, is from New Zealand, because you can hear that in her voice. And we have one child who's off at college who's also a Kiwi. And there's a running joke in her house about how Google Assistant can never understand her because they talk a bit differently. And so I find it interesting that you talk about handling accents, because they're tough to understand for a generalized system. Is your ability to be more accurate with accents based on the narrowness that you can get to by creating a custom model versus the generalized Google or Apple or Amazon models, or is there something else built into the technology? Is there something about the end-to-end deep learning that enables you to handle the accents better?
Yeah, so you can take both approaches, which is to have an end-to-end deep learning based general model that you feed a lot of data to and train for a long time, and it will learn all accents. You need a lot of data and a lot of time for that to happen, but it is true that works. And that's one of the downfalls to a traditional speech recognition approach, is they have they have things that are called like I vectors and other things underneath that try to adjust for each speaker. But you have a certain number that you can choose for every language, and once you start to go above a certain amount, it can't pick out all the different accents and whatnot. But that's not true of deep learning or the end-to-end deep learning approach. You can feed it all sorts of different noise profiles and accents, and it can adjust to it. The thing that it needs, though, is enough data in order to do it. And so the company that's training that model needs to prioritize the training data on that side. It needs to go collect unlabeled data there, and then it needs to label it and then expose its models to it over time in order to incorporate that accent. That's the general model approach, though, and you can do that for many accents, but it takes a lot of time, a lot of data, a lot of cost. The other side is if you know what the accent is going to be, then you can make a specific model for it, which is that targeted trained approach. And we're actually working on something in the background that we haven't released yet, but I could mention something about it, which nobody in the world has released yet either, which is more on the speech understanding side rather than speech recognition, which is if somebody is speaking, what language do you think they're speaking? Or what language with what accent? And then if you know that, then you can switch to a model that is specific to that accent or that language. And right now, if you were to use something like Google or Amazon or any other competitors out there, you have to select the language. You would have to select the accent, et cetera, which is just like a cumbersome thing for people to have to do every time they get on a call. Like if there's 5 people on a conference call, you're going to go through and select everybody's accent and which language you're using and whatnot. It's a product nightmare. But if you have the automatic side of that, then now everything is easy peasy. So that's coming. And so you can actually piece it all together in these different ways. And that's really like the flexibility of the end-to-end deep learning approach is you actually don't just have to do transcription with it, which is not true of the standard speech recognition approach, where it really is designed just for transcription. If you try to do anything else, like figuring out which speaker is speaking or which language it is or what accent they have, or, are they happy or not? They're not designed for that. It doesn't work. But the end-to-end deep learning approach, you just give it a new target now. Instead of words, you tell it, I want to know happy or not, or which language, or things like that. So that flexibility allows us to build new products like that.
So when you think about the ability for the model to automatically select what language or what language of what accent, is the customer of yours having to train a specific model for each individual language? So do you have to set up an English language model and a Spanish language model and a Japanese language model, or is it learning from the entire set of conversations that you're feeding it during the training process?
Yeah, good question. Generally, what's happening is you want it to happen as automatic as possible. We call it an autopilot mode, where your customers are just, your users are just using it, and then you start to aggregate data about who's like what's what, which different languages are being used, and which accents are being used, and then put more resources toward that. But you have to start out with a general model then first. So you don't have to actually sit down and train a model for every customer, for every accent, but like that would be a lot up front. What you do is you just start out with a general model at first, and then you start to specialize pretty automatically over time. It's just part of the way the system works in the background.
That's fascinating. So you can have a conversation where you have 3 or 4 people on the phone or in a meeting, and in the future when this comes out, right? This is in development. It'd be able to identify that Jane has this particular accent and Bob has that particular accent, and be able to listen to each of them, with speaking whatever language they're speaking, but with an accent to be more accurate in understanding what they're saying.
Exactly. Yep. And doing it automatically in real time. We really want to get down to the ability to do it word by word. And you can actually with many different words. However, there are some words that sound the same no matter what language it is. And so, like ni means you in Chinese, but it also means you're knee in English, so of course there's a tone there and whatnot, and you can discriminate there a little bit, but nevertheless, the goal there is to get down to the word level, because if you have people the technical term here is called code switching. If you have people who are code switching, which is going from one language to another, a lot of times they'll use single words from other languages. Like if you're speaking in Chinese, you'll use an English word, or English, back to Chinese or something like that. And you want to be able to detect down to that level. But the first version of these will be more like the, sentence level, something like that.
So one of the challenges more broadly in speech recognition, or I guess in sort of across AI, is an issue of bias. How do you think about bias in speech recognition broadly, and then also specifically, how do you help your customers, since they're training their own models? How do you help them handle bias?
This is a tough problem for all AI companies. You have to, you want to be inclusive, but you're also working with the raw materials that you have, like which data you have access to and things like that. But with the general approach, like just the one general model and what you see is what you get, that's sort of the most biased approach. And we look at the trained model as like somewhere in between where we want to be and where the general model is right now. But nevertheless, you can say, hey, maybe the general model isn't doing so great on a specific sector of the population that's using your product, but if you turn on that autopilot training mode, then it will automatically get better. The model will learn to adjust, and over time be able to do better on that population. That doesn't cover all populations, though, right? You have to have enough people in that using that product enough times in order to have it be incorporated. But nevertheless, it's at least a nice stepping stone to that. And honestly, like if any AI practitioners out there could snap their fingers and get labeled data from all accents, all ages, talking about all different topics, we would do it, And so the trick there becomes, how do you get access to it and make it cost effective to go label it? Because actually, it's something I haven't mentioned. Like the data labeling is just really, really expensive, and so the angle you have to take is how do I even find the unlabeled data, and then now how do I put together the group of people to label that data, and then now you can finally feed that into the trained model, and now it's actually a real data-driven approach. But that front end is actually really hard to do to find the unlabeled data and then go label it. But I think the steps that we're taking are, any time we hear about or see an accent or specific jargon or something that our model doesn't do well on, like we're on it, like how do we get more of that unlabeled data so that we can boost that subpopulation. So it's going to be that way. It's going to be like an iterative leapfrogging approach to actually, for every company to expand out and incorporate everybody.
I find it's such an interesting topic because we keep finding out things about our own human existence and human history that we didn't know, right? So because we're creating AI, because we're then identifying bias in it, we're having to trace back to figure out where that bias came from. I love the research that I came across not long ago that was talking about how the structure of pronouns in the English language creates bias in language. So, if you say the car is his or it's his car, it's the same masculine pronoun, whereas the car is hers or it's her car is two separate ones. And just that separation of pronouns and the way they're used in the English language creates bias at the root of the data. And I find that the challenge that we've got is we're not just setting a target to say we'd like to have data that is unbiased. We'd like to have systems that treat people in an unbiased manner. It's that we're chasing and finding sources of bias that we didn't even know existed before.
For sure, and what you're doing is sort of activating tools that make it easier to find them. And this is kind of what happens behind the scenes when you're building your data sets in order to train the model. You don't actually just sort of with a blanket brush just say, okay, label all data. Like, what does that even mean? There are things called like style guides or that tell you very specifically, like, what do you do with OK versus OK? And so what I mean is like the letter O and the letter K, if you were to write that down, versus like OKAY. And a very simple example, but maybe 1, 2, 3, 4, right? Sometimes you want it to be a numeral. Sometimes you want it to be the word one. Like, he gave me one of those. Do you really want it to be a numeral there? Maybe, maybe not. That kind of thing. You have to make choices like that, thousands of choices when you're building these data sets. And but anytime there's a hole that you notice, like, wow, the model does not do very well over here, then the AI data people are all over trying to find an unlabeled data set of that and then label it so that now you can actually cover that area really well. But it is a challenge.
I love the concept of a style guide for this. I'm sitting here smiling, thinking of a couple of years that I spent at Quartz, the news business, and the debates that go on in journalism over the Oxford comma.
Yeah.
And I'm trying to think of, okay, so what's the labeling system, and like whose style guide says you should use an Oxford comma versus who shouldn't? And the style guides get really quite intricate. If no one's ever actually been, I think journalism is probably the best example of style guides, and there are competing ones. They're quite different.
Yeah.
The Economist is different from AP, from everybody else, and each individual news organization will have their own. When you dig into that and you look under the hood, you realize that those style guides actually really matter, and they do change the meaning of what is written. Right, the way that you write, the way that you use words, the way you use punctuation, how you capitalize things or not, eventually means something different. And so the concept of building a style guide for data that then gets interpreted by a machine has this huge magnifying effect.
For sure. Yeah. And this really brings me back to the particle physics days for myself. So like, we think of what we do at Deepgram and how we build data sets and models and how we attack this problem, the speech recognition model and the speech understanding model. We're coming at it as scientists and not engineers. So I was a scientist before. I have a PhD in particle physics, and I built deep underground dark matter detectors, both in the U.S. and China, right next to the world's tallest dam, and also in an abandoned gold mine. So basically, James Bond layers underground. So it's a very, very fun time doing that. First of all, but also just the way that you have to attack the problem and the way that you're advancing sort of the edge of understanding of physics is actually very, very similar to audio. And what I mean is on the physics side, you have really messy data that you're taking underground. Basically, you have this type of experiment has a really significant radioactive background. So like everything is radioactive. Humans are radioactive. The bananas that you eat are radioactive. Everything, like rocks are, everything's radioactive. And these experiments are really, really sensitive. And this is why you have to go underground. If you put it on the surface of the Earth, the signals inside this detector would just light up like a Christmas tree, and you couldn't tell anything that was going on. So you have to go underground where it's way quieter. But even once you do that, you still have a background that's happening inside, and it's very messy. And now you have to pair that with an approach that you either use human-powered statistics, like you have graduate students and a lot of them try to figure out what's going on inside that detector. Or you can use some like simulation and machine learning approaches, which is like what we were doing then. And so there was like this shift from the old world to the new world where it was like hire 100 graduate students or hire 5 that know how to do machine learning. And you see this big shift. And when you do that, now you have a multiplicative effect on the computation side that allows you to point out areas where before, if you had like humans reviewing literally everything and making the plots and figuring out what to do, then everybody would get exhausted and you'd become patience limited. This is something we talk about all the time in AI. You want to be very mindful of the patience limitation and the motivation of people who are working on these problems. But nevertheless, in that world, if you had to spend 3 months in order to figure out a result, or 3 hours in order to figure out a result, you can imagine which one people would pick. But the old way was 3 months, and the new way using machine learning is like that 3 hours. And a similar thing happens in the audio world now, where the old way to attack problems was sort of just label whatever data you could find, whatever way you could, stick it into a model that has all these like broken contraption parts in it, but at least you could get something out of it, and then like sort of build a product around it and go to town, right? But it put a lot of man hours into it just to try to get it tuned up. That's not the approach anymore. You think about it more, rather than taking these pieces and try and fitting them together from an engineering perspective. You're thinking about it more from that scientific perspective of what is the data that I need, and what is the underlying compute power that I need, and what is the connection? What are the connections inside this model that need to take into account like tone or the temporal nature, the time nature, and the sequence nature. And you're starting to think of it now from this more basic sense. And when you do it that way, but you allow it to be put together, now you understand something about the world you're able to understand something about the world that you didn't before, because you aren't drowned in all of the details of just this implementation problem. So you discover things about language, and you discover like a very interesting thing that we discovered was that you couldn't do this before with old speech recognition techniques. And you'll get me excited here because it's really awesome. But nevertheless, if you train a deep learning model, an end-to-end deep learning model, to learn one language, and then you take a similar structure, a deep learning model, and train it to learn a different language, but they all start from scratch. They start from not knowing the other language or anything like that. They start from scratch, but they start with the same amount of data. Then let's say you learned, you did that, and it takes a long time to train these models, but let's say it takes like a year, okay, to go from this model that can't do anything to a model that's actually good. And then if you do it the other way, or you do it another way, which is have it learn English first, okay, and then it took a year to do that, fine. But now you want to go learn French, for example, and you take the same data that you did before, and each of them took a year before, but now you take that model and you allow it to transfer learn into French, and it actually takes a month now. And it not only did it learn French in a month rather than a year, but it actually learned it better than if it had learned it from French itself and only French. So there's like a collective knowledge in all of language that you can use, and we call it transfer learning because you're transferring knowledge from one domain to another domain, from English to French or whatever. And so this is just another indication of the power of end-to-end deep learning. And actually, it's still unknown how far you can take that. You're going to have to wait a few years to figure it out. But nevertheless, this is how we do language detection. This is how we do transfer learning out of speech recognition, actually. So I think it's so much fun, and you're discovering like fundamental laws of information in the universe rather than fundamental physical laws.
I love the story that you could learn French in a month. I studied French for something like 9 years and never really completely nailed it. So you always come in this field. You always come across places where you realize how much better a machine is at something than a human, and that's certainly one of them.
Yeah, and this is kind of a game internally at Deepgram too for a short while until the machine just like beat us all out, which is like how many languages does Deepgram know compared to the people at the company? And now it's like far more than any of the people at the company.
Well, how many languages do people at Deepgram speak?
Oh, it's in total fluently. I think it's 6, and we have 5, and we have 8 languages that are released now, and just more coming. And so we sort of just stopped keeping track because it basically you get a data set and it can learn it in a month, and so it's like you can't compete.
Facebook has published a lot about understanding other languages, understanding colloquial language, those kinds of things that come up in a Facebook thing. Do you follow what they do? Do you have any interpretations to share about what's going on inside of their system?
So, in particular, are you talking about like them? They had some press maybe a year or 2 or 3 ago that was around like their language models learning sub languages.
Yes.
Yeah. So, I mean, this is something that happens in most machine learning models because they have the ability to, because they aren't hard coded, they aren't a heuristics based approach. They have the ability to learn and adjust which features they care about. That means that if you start tying multiple systems together, they can just shortcut the whole process. Like another way to say this is that computers are, they talk to each other in integers and floating point numbers and strings and things like that, whereas humans communicate to each other via our eyes and ears, basically. And with your eyes, you can read things or see what people are doing with their body. With your ears, you're parsing out what they're doing via speech. But there's no actual perfect way to get information from one human to another. It has to go through a medium. It has to go through speaking. It has to go through showing them something or something like that. But with computers, that's not true. They can send information from one to the other with perfect fidelity. And what this means is that if the machine learning algorithms are able to take advantage of that fact, then they can just shortcut the whole process and say, like, A18743 means this, like, whole set means basically the equivalent of a paragraph, to a human. And so that's really what's happening in the background. I don't think it's anything that's like strange. It's just like, hey, humans have a limitation. Machines don't. When you allow the machine to adjust itself to flatten down and have a shorthand notation, then it can do it. That's great. That still doesn't mean it can do like amazing things like a lie detector or something. Humans are a lot better, at that task than machines. It's also like the novel data side. Like, why can't if the machine's so great, why can't the machine label its own data and train itself? Well, because it's very hard for it to learn new things. It can do things that it's seen a million times really well, but things that are new, it can't do so well. Humans are really great at doing novel things. They can see somebody do one thing with one example and then be able to replicate it. And this comes from the fact that we don't just hear the world. We don't just see the world. We also have temporal permanence in the world. We know that there are objects. We know that the objects generally don't disappear. We know all sorts of things about how the real world works, but machines don't. All they're given is an example, a piece of audio and some text that goes with it, or an example image and a label that goes with it, or something like that. They don't have that outside ability to understand. But that puts them at a deficit in certain areas, but on the flip side, because they can specialize and communicate to each other very quickly and with a very specific language, that means that they have a leg up in other areas too. And it's usually not like 10 or 20%, it's orders of magnitude.
Are you looking into getting into emotions?
For sure. Yeah. So this is a research area for us where, so we have we don't just have an engineering team at Deepgram. We have a research team as well. And these are the things that they work on that are more on the horizon, where you can understand if somebody's upset or not, or happy, or that's one base case. The other, like, just to name some here a little bit, like descending from least complicated to most complicated, you have speaker recognition, just like who is speaking or how many people are speaking, that kind of thing. You have like punctuation, which is something that's interesting. Humans know how to do it really well. Machines can do an okay job with it. Then you have like this language detection, and now descending into more context aware, like what about topic, what about emotion, all of these things are being worked on by our research team at Deepgram. And the way that we look at what we're doing is, we're not like, we do sell a speech recognition product now, but really there's a new type of company that is being built, it's a speech understanding company. So if you have a lot of data and you need to know what's inside it, like in the example of, you have a call center and you have data scientists, and those data scientists are saying, hey, there's gold and then there are hills, where like all this data and we're just not doing anything with it. We could figure out what our customers prefer. We could figure out what they're angry about. We could figure out if our agents aren't doing a good job, or if they are, or if maybe we're going to get sued, or something's not compliant, or something like that. Now, that side can partially be filled with speech recognition right now. You have to have your data scientists involved in that. And that's basically the only way to do it right now. But in the future, you'll have products that allow you those higher order pieces of information. So it's not just the words that you're hearing anymore. It's the emotion that the person was feeling when they were saying it, and it was who was saying it, and it was picked out to be like, this is compliant or not, or this is interesting or not, or things like that. So yes, we're working on it.
I love that, the speech understanding company. That's a nice, that's a great future vision. This has been a real pleasure. Thank you so much for taking the time. It's been wonderful to hear what you're up to at Deepgram. I know you've got quite a lot of future ahead of you. Congratulations on the recent venture funding, by the way. In a difficult environment, it's a big deal to raise capital right now. But thank you very much for your time. This has been really fascinating, and I can't wait to see how the product evolves.
Thank you so much. Yeah, we are really proud of what we've been able to accomplish, and our investors are really excited about the next step in this speech recognition to speech understanding side. And thank you so much for that.